Hi, I'm Pat Kelly. Okay, and so in this lesson we've been learning applications of our differential equations, which is neat to see how they can be used in the real world. And I'm going to give you the heads up that a lot of times you'll need a calculator too then for some of these problems because the numbers in the real world aren't always that friendly for us. So in this problem, they give us this model, this differential equation, and this general solution to it. And then we're supposed to apply these initial conditions in order to come up with a specific function of a y as a function of t, a particular solution to this differential equation. Okay? So in order to do that, we're going to utilize this general solution and put in these specific initial conditions. Now give me these two different initial conditions. I'm just going to plug those pieces of information into the general solution one at a time. And I would definitely go for this first one first, because 0 is very much your friend when we're doing some calculations in these problems. So I'm going to plug in my y equals 0 and my t equals 0, plug into the general solution. So for my general solution, I have y equals 1 minus c e to the negative kt. That's what was given to us. Now we're just going to plug in that specific value for y of 0, and also separately, different value of 0 that t is also 0. Y is 0 equals 1 minus c e to the negative k, 0. Just making sure things are lining up for you in terms of that 0 being the one for t and this 0 being the one for y. Okay. Now we'll evaluate. This is 0 equals 1 minus e raised to the 0 power. That's just 1 minus c. So c equals 1. That gives us a specific value of c to put into this general solution. So now as I move on to my second initial condition, let's try to use that. I can put in that value of c, 1, right there. And I'm using y equals 0.75 this time, and I'm using a t equals 1 this time. That's the information they gave me. Now I'm going to try to put that into my general solution, y equals 1 minus. As I mentioned, this c we now know it's 1, so that's just e raised to the negative kt. And now I'm going to put in the value for y, 0.75 equals 1 minus negative k, and I'm also putting in that value for t of 1. And we'll try to simplify. 0.75 equals 1 minus e to the negative k. I'm going to try to solve for k. I would subtract this 1 to the other side. Negative 0.25 equals negative e to the negative k. Let's also even multiply each side by a negative 1. Make it a little friendlier looking. And that's friendly looking enough that I can solve this equation with logarithms. This is a case where negative natural log of 0.25 is going to equal k. You've done those types of equations before. This is why I mentioned the calculator, because you're just going to go ahead and evaluate that natural log of 0.25. .386. The natural log is actually negative. There's a minus sign in front, so it's going to be positive overall. And that's going to be my value for k. So I feel a sense of accomplishment. I have a value for c, I have a value for k, and so to put it together for a final answer, I go back to my general solution one more time, but I use those specific values. Y equals 1 minus 1 e raised to the negative 1.386 t. And that would be my answer. That's the particular solution for this differential equation, given those initial conditions. I hope that helped. Thanks.